What if we dumped our trash into volcanoes? We have a trash problem, a massive one, and it's getting worse every single day. Each year, humanity produces over 2 billion tons of solid waste. That's not just a big number, it's enough to bury Manhattan under mountains of garbage several times over. Or put it another way, picture more than 800,000 Olympic-sized swimming pools filled to the brim with trash every single year. And the trend isn't slowing down. As developing countries industrialize and consumer culture spreads, that number is expected to jump to 3.4 billion tons by 2050. Landfills are filling up faster than we can build new ones. Microplastics are now found in the deepest parts of the ocean and inside the bodies of marine animals. Even our most remote ecosystems are starting to show signs of pollution. Meanwhile, our recycling systems are failing to keep up. Much of what we think is recycled ends up being incinerated or sent to other countries, some of which are now refusing to take our waste. We're running out of places to put all this garbage. So naturally, someone eventually asks, why not throw it into a volcano? Volcanoes are hot, insanely hot. We're talking temperatures that can melt metal, vaporize water, and even cause stone to bubble like molten wax. So could we use the Earth's natural incinerators to deal with our ever-growing trash problem? Today we're exploring this explosive idea, breaking down the science, the logistics, the dangers, and whether volcanoes could actually be used as planetary garbage disposals. Spoiler alert, it's not as crazy as it sounds, but it's also not the magical solution we might be hoping for. Visuals, cross-section of a volcano, animated graphics showing lava temperatures and melting points of common materials. Garbage items labeled and dropped into a simulated lava flow. Let's start with the basic premise. Why would anyone even think of throwing trash into a volcano? The core idea is simple. Lava destroys things. The molten rock found in volcanoes can range in temperature from 1,300 to 2,200 degrees Fahrenheit, or 700 to 1,200 degrees Celsius. That's hot enough to incinerate wood, melt many metals, and obliterate just about any organic matter. Plastics, gone. Old furniture, disintegrated. Your broken blender, expired food, and that pile of outdated cell phones, reduced to ash or vapor. So the concept isn't entirely ridiculous. In theory, lava could function like the ultimate incinerator, one that requires no electricity, no fuel, and no moving parts. It's the planet's own built-in trash burner. But here's the first catch. Lava lakes are incredibly rare. Not all volcanoes have them. In fact, out of the thousands of volcanoes on Earth, only a handful maintain persistent, accessible lava lakes, the kind you could theoretically toss garbage into. Examples include Mount Nyiragongo in the Democratic Republic of Congo, Kilauea in Hawaii, Erta in Ethiopia. These lava lakes are volatile, unpredictable, and often located in remote or protected areas. Accessing them safely, consistently, and at scale would be a monumental challenge. Even assuming access wasn't a problem, how much trash could a lava lake actually handle? We're talking billions of tons of waste annually. Lava lakes, as awe-inspiring as they are relatively small. You can't just line up dump trucks and unload tons of garbage every day. At most, you'd be managing a symbolic fraction of global waste. So while the heat is certainly there, the scale? Not even close. Let's pretend for a moment that we could access one of these lava lakes safely. The next challenge: getting the trash there. Most of the world's trash is generated in urban centers, major cities, industrial zones, and residential areas. Active volcanoes, on the other hand, are typically located in remote, rugged, and often dangerous regions. Transporting millions of tons of waste to a remote volcano would require thousands of long-haul trips by truck, ship, or even air the construction of roads or landing pads on treacherous terrain. Enormous fuel consumption, leading to even more carbon emissions. The environmental impact of moving the trash alone could cancel out any potential benefit of using lava to destroy it. And let's not forget, volcanoes are notoriously unstable. Even dormant ones can erupt unexpectedly. You don't want convoys of waste-laden vehicles stuck mid-slope when the next eruption hits. There's also the matter of cost. The logistics of waste management are already expensive. Add in high-risk transport to an active volcano, and you've got a budget-breaking operation that's likely to be more trouble than it's worth. So let's say we overcome the odds. We get our garbage to the volcano. Now we just need to toss it in, right? Not so fast. When garbage hits lava, especially if it contains moisture or volatile chemicals, The reaction can be violent. The sudden temperature shift causes any water content to instantly vaporize, creating steam explosions that can hurl molten rock, gas, and debris dozens of feet into the air. This is more than theoretical. In real-world experiments, scientists have observed that tossing even a small organic item into lava can trigger explosive outbursts. Now imagine throwing in tons of mixed garbage: plastics, metals, batteries, paint cans, electronics. Not only would this cause explosions, but the burning process would release a dangerous cocktail of toxic gases: dioxins and furans from plastics, hydrochloric acid, and sulfur dioxide, mercury, lead, and other heavy metals. These aren't just bad for local air quality, they can travel long distances, harming ecosystems, animals, and human populations miles away. The release of such gases can also contribute to acid rain, respiratory illnesses, and long-term environmental degradation. So instead of solving the waste problem, you've now created an air pollution crisis, one that could spiral out of control. Some visionaries believe we could create artificial volcanoes, or at least industrial-scale lava simulators, giant chambers filled with molten rock or other materials that mimic the heat and destruction of real lava. These could, in theory, be built near urban centers, reducing the need for long-distance transport. With the right filtering technology, the emissions could be scrubbed clean, minimizing the environmental damage. In fact, this isn't that far off from current waste-to-energy plants, which burn garbage to generate electricity. The most advanced facilities already have emissions control systems that limit the release of toxins. But even these aren't perfect. Burning trash still produces carbon dioxide, and certain materials, especially plastics and electronics, produce toxic byproducts even under controlled conditions. There's also the leftover ash, which has to be disposed of somehow. So while tech might offer part of the answer, it's not a silver bullet. If volcanoes aren't the answer, what is? It starts with changing our relationship with waste. That means designing products that are durable, repairable, and recyclable, reducing single-use plastics and excess packaging, creating economic incentives for companies to take responsibility for the waste their products create, investing in composting, recycling, and reusing systems that are more efficient and less harmful. And most importantly, it means producing less waste to begin with. No volcano, machine, or magical process will solve the root problem if we keep generating garbage at unsustainable levels. Volcanoes are some of the most powerful and beautiful natural features on Earth. They shape continents, birth new land, and remind us of the immense forces beneath our feet. But they're not trash bins, and trying to use them that way reveals something deeper: a desire to erase our problems instead of facing them. The real answer isn't to burn our garbage away, it's to change the way we live, consume, and think about our impact. Because when it comes to the future of our planet, the fire we need most isn't in the lava. It's in our determination to do better. Thanks for watching this deep dive into the molten heart of a big idea. If you enjoyed this video, give it a like, subscribe, and ring that bell for more curious questions and surprising science. Have a wild what if you want us to explore? Drop it in the comments. Until next time, stay curious and keep it clean.